Oh boy, a bunch of NPM packages got exploited. Again. For like the 5th time this year. If you've watched my previous coverage of these NPM exploits, you might remember a particular thing that I called out. The way the hack worked was actually pretty clever. It looked for strings that roughly matched the shape of a cryptocurrency address for various different cryptos. And if it saw one, it would swap it out with one of the like hundreds that they had hard-coded in that looked similar enough, like it had a start and an end that were vaguely similar. So if they swapped it out, you were less likely to notice the address change before hitting send. Honestly, pretty clever, except for the fact that it only affects front-end packages that are bundled into your application. So the only way this could have affected you is if you were on a website that used an affected package that had since done the update, installed that package, and then had it bundled into the website and the new version of the site shipped with that affected package. That is a surprisingly large number of things that have to happen in a short 8-hour window in order for this to affect you. So of the 19 packages that were affected, one could reasonably have been included on the front end. The vast majority of the packages that were hit here don't work with the hack that they had built. But because these hackers are not very good at their jobs and didn't have a hack ready to go for backend focused node packages or tooling focused ones in a similar regard, they were embedding a front end hack that requires certain things like fetch and DOM node access to work. Yeah, it was effectively luck that these exploits didn't cause massive problems before, and our luck appears to have run out because the most recent supply chain attack has done potential actual damage this time. We're no longer theory crafting. We're no longer seeing hypothetical attacks that could cause damage. It's happened. We're here now. And we were almost affected ourselves with T3 chat because one of our dependencies, PostHog, got hit. We've identified a number of our library versions published earlier today contain malicious code. We are currently deprecating those versions from our package managers and will republish clean versions of the libraries. The impacted versions we've identified so far. There's a lot of layers to this, from how maintenance of large dependency trains and trees work, to how bad NPM is about letting you unpublish a version of a package, to the utter fucking chaos that is dealing with this all in a system as big, diverse, and risky as NPM is. On one hand, we're lucky we haven't seen much more stuff like this. On the other, it is time for some serious change in order to make sure the applications we build and the ecosystem we build with manage to stay safe, especially in a world where we're going to be reading less and less of the code that we ship. It's increasingly apparent that I could make a lot of money if I chose to ship some sketchy packages and steal access to credentials that I shouldn't, but I'll never do that. Instead, I'll take some money from today's sponsor. My business T3 Chat is doing quite well. A lot of people seem to think that's because I'm popular, but you can kind of buy popularity. You can hit people up like me and convince me to talk about your product. That's not where my popularity is helping me. There is one huge advantage it gives me, though. My hiring pipeline. I have the best team in this industry. There is no world in which another company can beat us simply by the quality of the people that I was able to hire. I am so lucky to have this incredible community of people to hire from, but not everybody does, and chances are you certainly don't. You go pay a recruiter to spam people on LinkedIn, or you could get into the best network of engineers in the world and hire only what you need at the highest quality bar without having to worry about all of this stuff taking forever, costing so much money, and getting crappy hires as a result. That's why you really should check out today's sponsor, G2I. This is the best way to hire great engineers without wasting all of your time and money to try and find a decent one or two. Their 8,000 engineer network isn't a bunch of random college grads. These are people who have actual industry experience and are ready to go from first interview to first PR merged in under a week. It sounds insane, but I've seen it happen enough times that I actually believe it now. G2I is the recruiting team that you're looking for, the best platform for hiring that's ever been made, and the quickest path for you to get the right engineer for however long and however experienced you specifically need. There is no better place to do hiring, and when I have companies that are looking, the first people I throw them at are G2I. You want to see why I recommend this to all of the startups I invest in? Check them out now at soydev.link/G2I. Shai-Hulud strikes again. Another wave of the Shai-Hulud campaign has hit NPM with more than 500 packages and 700 plus versions affected. Multiple NPM packages from Zapier, Async API, Postman, PostHog, and ENS domains have been compromised via account takeovers and developer compromise. The malicious actor has made the following changes in these packages. They added a pre-install script, setup_bun.js in the package.json file. Yeah, it's a bun setup. Clever to sneak in this new thing people are excited about as a way to actually exploit stuff. It's a stealthy loader that silently installs or locates the bun runtime and then executes a 10 megabyte obfuscated and bundled malicious script, bunenvironment.js, with all of the output suppressed. So how did this happen? It was a two-stage loader. NPM would run a pre-install script where it would execute the setup bun.js. Pre-install scripts are super sketchy, and thankfully more and more package managers are just refusing to run them without authorization. The point of a pre-install script is when you run the install, it can do things. Post-installs are also a little sketchy, but not quite as bad. The idea is that when you install this package, it can run some code before or after that does something. A good example of this is with Prisma. When you npm install Prisma and it sees a Prisma package or directory in your project, it can then run a code gen step that will update the Prisma module in your actual code base to have the types for your Prisma schema. That's great when you want your ORM to know what data is in your database. But the fact they do that via a scary script that has to generate that code right after you do the install, that part's a little weird. And this can be exploited heavily by malicious actors. So this pre-install script we're talking about here would detect the OS architecture, download or locate the bun runtime for that specific platform. It would cache the bun binary in a cache directory, spawn a detached bun process running this bun environment file, and then it would suppress all of the standard out errors and immediately return. Package installation completes normally while the payload runs in the background. C2 discovery via GitHub search. Before executing the main payload, the malware attempts self-healing by searching public GitHub repos for the beacon phrase, Shai-Hulud, the second coming. If found, then it would read a stored file containing a GitHub access token, decode it through 3 layers of base64, and then use that recovered token as the primary credentials for exfiltration. The 3 times base64 thing is clever because it means that you're not like shipping a signature or a key that is detectable, but you're also not going to notice this because if you try to do a base64 decode on something and the result is more nonsense, you're not going to assume that it is meant to be something else. But base64ing 3 times, that's a weird, clever way to not ship a key that's identifiable. It would then fingerprint the environment that it's on, detect CI and CD environments by checking for GitHub actions in the runner OS, build kite, code build, and all these other flags and variables that might exist if you're in a CI environment. And if you're in GitHub actions, it would try to gain root access through sudo manipulation. If it has sudo access, it'll use it. And if it doesn't, it'll try to exploit Docker privileges in order to write a new sudoers update that allows it to have sudo access. And apparently this works for malware to have passwordless root access on GitHub actions. Great. Once it's privileged, it would do some DNS and firewall manipulation. It would stop systemd resolved. This will prevent the action from dying, is my understanding. It would replace the DNS configuration, restart the resolver, and then flush the IP tables. And now it has a man in the middle in your CI. So any network, anything you're doing there now is going to be run through this DNS layer that they hijacked to see all the traffic. And they can redirect package installs to malicious mirrors. They can block security scanners from reaching the internet. They can even prevent security updates. Terrifying. So here's some of the stuff that they do once they get there. They collect your environment variables. Joy. This can get everything from your AWS keys to your OpenAI keys for inference and all these other things. Like you don't want these companies getting your Stripe keys. And now these sketchy malicious actors can get them. They also use TruffleHog to scan for hard-coded secrets so it can find any secrets that are in your code base. They then try to call cloud provider APIs to see if they can access things for AWS, GCP, or Azure. This call here is using the package for AWS, if it exists, to try and access the run secrets variable or function and get the secrets for AWS if it's there. Same with GCP, same with Azure. The AWS module loops through every available region, enumerating and dumping all secret values from AWS's secret manager in each. This regional sweeping is unusually aggressive and significantly increases the credential harvesting in multi-region deployments. Terrifying. And then it sniffs your GitHub action secrets with an automated credential scraping. God. Any one of these would be so bad it's horrifying, but it keeps getting worse. Data exfiltration. It would create a GitHub repo using the victim's account using the stolen GitHub token. The repository name would be randomly generated. Some repos are created with the description Shai-Hulud, the second coming, as a campaign marker. These guys love to brag about their success. And then the triple base64 encoding. Oh, look at that. I called it. I knew why they did this. It evades the built-in secret scanning. It bypasses third-party secret detection tools. It makes casual browsing of repos like you just don't see anything when you scroll through this looking for it. and it complicates the forensic analysis of the data that they steal. Then it uploads 5 JSON files to the victim's repository. The system info, the environment variables, AWS GCP Azure secrets, truffle log findings, and GitHub action secrets. And it publishes this as a public repo so they can be scanning GitHub constantly for these specific flags and then grab the tokens quick. And here's how they propagated. They would look for NPM tokens, I'm assuming during that CI hijacking. And if it found one, it would validate against the NPM registry, fetch all the packages by that maintainer, and then call update package on each, which would download the package, inject the setup files, patch the package JSON to add the pre-install script, bump the patch version. So if it's 1.0.0, bump it to 1.0.1, and then publish the malicious version. And since a lot of people have their deployment for NPM set up on GitHub Actions, this is going to hit a ton of shit, including what we just saw with PostHog. I assumed that it was one of their dependencies was malicious and that dependency was being included. But it seems like an actual malicious version of the PostHog packages was published with the code in PostHog itself. This is the exact opposite of the previous hack that I covered, where the developers didn't seem to understand anything about the JavaScript ecosystem. These guys know it really well and seem to have squeezed every ounce of potential exploitation out from here. There's also a general token mining that it runs in the GitHub action looking for anything that's prefixed with npm underscore in order to create this full CI to npm takeover chain. So a compromised GitHub action workflow would reveal npm tokens stored as secrets, which are then used to poison additional packages. This automated pivoting mechanism enabled the worm to bootstrap propagation even without direct npm token environment variables. And if it doesn't find anything useful there, it will self-destruct. Oh wait, it's not just deleting itself, it's deleting everything it can touch on your system. In Windows, it deletes all the files in your user profile, it removes directories, and overrides all free space with a cipher call. And on Linux and Mac, it finds all writable user files, shreds them with a single pass overwrite, and then deletes empty directories. I was curious how we're not that far scrolled in this. You can see the scroll bar on the right's less than a fifth the way down the page. The reason is because the rest of the article is all of the packages that they know were infected so far. Do you see the problem here? 834 were hit that we know of so far. PostHog did a postmortem too on their fake OS website. Let's take a quick look at this. So how did this happen? PostHog's own package publishing credentials were not compromised by the worm described above. They were targeted directly, as were a number of other major vendors, to act as a patient zero for the attack. So PostHog was one of the first victims that were specifically targeted. The first step that the attacker took was to steal a GitHub personal access token for one of their bots, and then use that to steal the rest of the GitHub secrets available in their CI runners, which included this NPM token. These steps were done days before the attack on the 24th of November. At 5:40 on November 18th, now deleted GitHub user BRWJ, just random stuff, opened a pull request against the PostHog repo, including this commit. This was a fixed typos PR, and it adds this output is exec sync webhook.site / great. I'm sure that's not super sketchy. The PR changed the code of a script executed by a workflow that we were running against external contributors, modifying it to send the secrets available during that script's execution to a webhook controlled by the attacker. This is why it's so scary to run CI against PRs that people outside of your employees and team file, because anyone could file a PR that does something malicious, and if it executes in any environment, they can probably do some sketchy shit with that. And that's what happened here. The secrets included the GitHub personal access token of one of the bots, which had broad repo write permissions across the org. The PR itself was deleted along with the fork that it came from when the user was deleted, but that commit wasn't. The PR was opened, the workflow was run, and the PR was closed, all within the space of 1 minute. And then 5 days later, the attacker used the credentials to delete a workflow run. We believe this was a test to see if the stolen credentials were still valid, and it was successful. So 20-ish minutes later, not even, 15 minutes, they used the credentials again, but to create another commit that was masquerading, by chance, as the report's author. We believe this was randomly chosen branch on which the author happened to be the last legitimate contributor, given the author does not possess any special privileges on his GitHub account. This commit was published directly as a detached commit, not as part of a pull request or similar. In it, the attacker modified an arbitrary lint PR workflow directly to exfiltrate all of our GitHub secrets. Unlike the previous PR attack, which could only modify the script called from the workflow, and as such could only exfiltrate the bot's personal access token, the commit had full write access to our repo given the ultra permissive personal access token, which meant that they could run arbitrary code on the scopes of their GitHub action runners. So now they can control all of the runners, all the GitHub actions, and get whatever else they want from there. And since the attacker would delete workflow runs after they completed, it was really hard for them to audit and identify these things. At this point, they had the NPM publishing tokens, and 12 hours later, at 4:11 a.m. UTC the following morning, they published the malicious packages to NPM, which helped start the spread of this worm. PostHog was not the only vendor used in the initial vector for this broader attack. We expect other vendors will be able to identify similar attack patterns in their own audit logs. So why did this happen? PostHog is proudly open source. That means a lot of their repos frequently receive external contributions. Even my team has contributed to PostHog, which is really cool. They automatically assign reviewers depending on which parts of the code base the contribution changed. The GitHub code owners file is typically used for this, but we want the review to be a soft requirement rather than blocking the PR for internal contributors who might be working on code that they don't own. They have this workflow, which is supposed to do that, but it never worked for external contributors since it required manual approval, defeating the purpose of automatically tagging the right people. So one of the engineers figured out that this is because it triggered on pull request, which meant external contributors who are coming from forks don't have the workflow run. So they changed it to on pull request target, which is a different call out in the YAML that causes the trigger to run whenever any PR is formed on the repo, not when a pull request is made on a branch from the same repo. This change seems safe, as their understanding was, okay, this runs the code as it is in the master or target repo. But this only ensures the workflow is being run as defined, not that the code is the right code, because it could be any code running there. They assume that the code running on this would be the code from the repo, not the code from the pull request, which isn't true. They just set up arbitrary code execution on their own runners. If you need more proof that GitHub CI is not easy enough, here you go. One simple innocent change, adding _target to make it so that this would run for external contributors, open them up to remote code execution on their servers. Well, not on their servers, on their CI. Same difference. Insane. And this is why they merged that change, because it was seemingly innocent. Like one of the employees wanted this to give better feedback for external PRs. Whoever reviewed it thought the same. This was totally fine. And none of them noticed a security hole in the month and a half before the PR being merged and this attack occurring. And I'm sure there's lots of other places, lots of other repos on GitHub that have the same problem. Workflow rules, triggers, and execution contexts are hard to reason about. So hard to reason about that GitHub is actively making changes to make them simpler and closer to our understanding above. Although in our case, these changes would not have protected us against the initial attack. There's also been copycats trying to copy this particular attack, and they've had to do frustrating manual and uncertain measures to prevent it. The changes GitHub are making to the behavior of pull request target would have prevented those copycat attacks automatically for them. And here is how they're fixing this going forward. Way more scrutiny, tightening the package release workflow, using the PnPM10, which disables pre-install and post-install scripts. Very good. Once again, use a good package manager. Helps a lot of these things. They have a security person there. They're doing the right stuff here. They're making good changes. And they're not the only ones. NPM has this banner on the top of the site. NPM Classic Token creation is now disabled. Existing Classic tokens will be revoked on December 9th, 2025. Migrate to trusted publishing or granular access tokens to avoid disruption. They're trying to get rid of these blanket tokens you can do anything with because they're a huge security risk. So how can we prevent this as a whole? You got to secure your CI/CD. If you have any of the packages listed above, remove them immediately and delete your no modules folder. If these packages were installed in environments with access to secrets or credentials, rotate all API keys, tokens, and passwords immediately, so the malicious code may have exfiltrated sensitive info. Follow the OpenJS guidance and understanding for the pros and cons of different approaches to publishing to NPM. Check GitHub for strange repos like those pictured below with the description of Shai-Hulud, the second coming. Yeah. You see any repo or had any repo that looked like this at any point, nuke all of your secrets, you're fucked. Socket, who wrote this article, has a free GitHub app that can help as well. I really like the Socket guys. Definitely a thing worth considering if you want to help prevent this type of stuff. They even have a firewall which will block malicious dependencies before they even get to the machine. Well, it happened. This stuff's always been fragile, but it's actually interesting here that NPM doesn't seem to be the fragile piece. I just assumed it would be. It's GitHub. It's CI. It's a way of punishing open source developers for doing things in the open. Like if PostHog wasn't open source, this wouldn't have happened. It's kind of crazy if you think about it that way, that this is a result of open source like maintainers and developers sharing the way that they build publicly, allowing for malicious actors to sneak in and run things through the act of filing a pull request. My biggest fear is that this results in both FUD around NPM and the JS ecosystem, but also results in more incentives for companies to not open source. Those are the wrong two lessons to take from this. If your assumption after seeing all this is NPM's insecure, no one should use JavaScript for their packages, and open source is bad because you might get hacked, I have a lot of different bridges I would love to sell you. Hit me up. The lessons here are that CI is complex, and it's important to make sure that your CI processes don't allow for a malicious actor to run things you don't want them to. There's a lot of ways that can happen, be it through the flag we just saw for the trigger for what code is running on the box. It could be that you have pre-install and post-install scripts that are very sketchy and can cause problems. It can be a lot of different things. But it's important as a developer to know what lets code run on your systems and not let code run that you don't want to have run. This isn't a problem specific to JavaScript or any other language or any other tool set. It's a problem that is the nature of allowing for code to be executed dynamically in any environment, like CI. So if you think AI is going to replace all of our jobs as engineers, go get into security. Seems like you have a lot of things to do ahead of you. Go make sure you didn't install any of these malicious package versions and clear your secrets if you do. Hopefully this was helpful, and hopefully we're a little more scared, but not in a way that's irrational. Be careful with GitHub Actions and anything else that allows for code to be executed. And until next time, peace nerds.